This is number 7. This is the perfect example of what an AP question does. It takes something that you know how to do, like find the slope of a line, find the equation of a line, and then it gives it a real world spin so that you have to figure out what it's looking for. So this is like what half of your test might look like if you think about it, okay? So it says the median player salary for New York Yankees was $1.5 million in 2007 and $1.7 million in 2013. Write a linear equation giving the median salary Y in terms of the year X. Let Y be in millions of dollars and let X equals 7 represent 2007. All right, so you have to interpret this. First of all, it tells you X is the year and Y is the millions of dollars. So the information they give you is actually just coordinate points written in word form. So if in 2007 it's 1.5, that means 7, which represents the year, would go with 1.5 million. And you can keep it in terms of millions, like you don't have to move your decimal over. And then the other piece of information that it gives you, and the numbers might be different for yours, but the other piece of information it gives you is that in 2013, which means 13 is your X, then it's 1.7 million. And now you've just got 2 coordinate points. And we're going to write a linear equation finding slope. So slope is going to be 1.7 minus 1.5 over 13 minus 7. And I get 0.2 over 6. And it said... It didn't say what to keep it as. It would take a decimal as long as it terminated. In this case, it was a fraction. So if I have to move this guy over, I got to move this guy over. 2/60ths becomes 1/30th. And then that's your slope. So notice that's here, okay, with the X. Then you have to find the equation. So you can either do point slope or you can do slope intercept. If you do point slope, then you'd get Y minus, and I can pick either point here. So if I pick this guy, Y minus 1.5 equals 1/30th times X minus 7. And then I get Y minus 1.5 equals 1/30th X minus 7/30ths. Okay, 1.5 is 3/2. And then I can add the 3/2. And I get Y equals 1/30th X. And the X can be in the top or on the right-hand side. It doesn't matter. Give this a like denominator. I have to multiply by 15. Negative 7 plus 45 over 30. So plus 38. 30ths. Or 19/15ths. I would say usually on a question like that, if you're like mentally preparing yourself for an actual test, if it's weird numbers, if it's decimals and that kind of stuff, it tends to give you a graphing calculator on those questions. And in that case, I'm going to teach you a method where you can literally type those points in and it can give you the equation. But more often than not, I would say this is a more like, it's maybe in fraction form to begin with, something like that, and then you wouldn't have a calculator. So you definitely need to know how to be able to do something like that. Now, the second part of this says use the equation to predict the median salary in 2047. So that means they want your X to become 2040 or 47. So I simply can take that and I can plug it in. So 47 over 30 plus 19 over 15. And this you would for sure have a calculator for. And that would give you that 2.8 million. I will also show you, like you could type this equation in like we did with the shapes of the curves, like the parabolas, the cubic functions. We went into the Y equals and we could type that in, and then you could go into your value and make it the 47 or whatever your year was, and it will also give you that coordinate point. So that's a good use of your calculator in something like that. Instead of having to plug it in, it's faster to plug in the equation and then go to value. Questions? Okay. Because you're obviously an AP exam is not going to say, here's 2 coordinate points, give me the equation of a line. That's not what happens. It's stuff like that. It's the application of it. So today we're going to get into 1-2, which is functions. We're going to talk about what is a function, how do you know something's a function, how to evaluate a function. We're going to get into piecewise functions, and then this section, which we'll do tomorrow, ends with something called the difference quotient. So there's a lot of stuff in this. So the first is like, what is a function? So the function by definition is a rule that assigns to each element x in set A exactly one element y. And what does that mean in like normal language? Okay. No x can be repeated with a different y. If I'm looking at an equation, the way that would happen is if y was raised to an even power or y was an absolute value. So if either of those things happen, then it's not a function. So in the beginning, it's going to be a simple like, is this a function, yes or no? And then we're going to learn how to evaluate it. And we'll do the, is it a function, yes or no, in this section based on points and equations. And then in the next section, we get into graphs. And that's where we bring in that vertical line test, if you remember that from Algebra 2. So because it already says it's a relation, it has to pass that test. And a relation can't have a repeated x, so I changed that. So A has it can't have a repeated y. 2, 4, 3, 5, and -2, -4. So the rule is the x can't repeat with a different y. If I look at all my x values and they are different, then it passes my function test. So this is a yes. I don't even have to look at the y values because it already told me it was a relation. B, I'm going to look at the x values. So if I look at all my x values, does an x repeat? Yes. Now, if it repeats and it's the same point, if this was a 5 and I just had 2 5 listed twice, then it's still yes. But if it repeats and it has a different y, like it does in this case, then it's a no. It is not a function. If I were to actually plot those points, it would be 2, 5, and 2, 6. They'd literally be stacked above each other or below each other, and that cannot happen. If you remember your vertical line test, that would fail my vertical line test. So it can't happen. All right, now with an equation, what would make it not a function? What am I looking for?
Y is raised to an even power.
Good, or?
Y is absolute value.
Good. What is y raised to, like, what is a y squared equation? What kind of graph is that? The parabola turned on its side, right? So if I turn it on its side, it's going to have points stacked above and below each other, which is why it doesn't work. So if I look at C, is that a function? Yes. That's a regular parabola. Opens up or down, that would be fine. D, is that a function? No, because this y is raised to an even power. And E, is that a function? No, it's an absolute value, which would be a v, but the y is in there, so it's a v turned on its side. Good? Yeah. D, this would be like a parabola shape, so that if the y is turned on its side. So if the y is raised to an even power, it's a no. Yep.
What about E?
The absolute value, so that would be a v, but turned on its side. So like this, why am I not writing? Like that, right? You would have y stack above and below each other. So it wouldn't work. That's fine. That's a regular v. So the y is what you're looking for. The y can't be raised to the even power, and the y can't be an absolute value. All right, now we're going to evaluate a function. And this is something that both standardized test and your SAT love. So you'll see this all over the place. If I said to find f of 2, that means take 2 and plug it in, okay? That's like evaluate the function if x is 2. That means the same thing. Find the value of y when x is 2. All of that means the same thing. So it says evaluate the function at the indicated value. And this time it's going to give you an f of x. This time's f of x is x squared minus 1. And A says find f of -3. So that -3 goes inside the x in parentheses. So it's -3 squared minus 1. Why is it important that you put it inside the parentheses? Because of the negative. What's the difference between this and this? Good. First one is positive. Second one is negative, right? If there's not parentheses, then we square the number first and then take on the negative. So those do not mean the same thing. So you got to make sure you plug it in inside parentheses. Now this becomes positive 9 minus 1, which is 8. F of 2, we plug in. 2 squared minus 1, 4 minus 1, which is 3. And then C gives you a binomial. So we take that A plus 2, we plug it in. A plus 2 squared minus 1. Now what you do not do is distribute this 2. That is not a squared plus 4. That is wrong. You have to either expand and FOIL this or use the shortcut. So I'm going to expand and then I'll go over the shortcut. But this is a plus 2 times a plus 2 minus 1. And then it's first, so a squared, outer 2a, inner 2a, last 4, minus 1. And then we combine our like terms. A squared plus 4a plus 3. You have to simplify if you can. So you can't just leave it as a plus 2 squared minus 1. Now the shortcut, because we're going to use it like sporadically a lot. When you are raising a binomial to a square, then the shortcut is square the first term, so it'd be a squared. Square the last term, so it'd be plus 4. And then double the product. So 2 times 2a is a positive 4a. And then I'd still have to do the minus 1. But that square, it's a shortcut just to square any binomial. Square the first, square the last, double the product. Questions on those? So if you had, let's say if you had a graphing utility, like on your test you would not have a graphing utility on this question, but let's say you did, then I could go to the y equals on my graphing utility. I could type x squared minus 1, and then I can do value, and I can hit -3, and it will give me the y, and I can do value, and I can do 2, and it would give me that y. So that's a quick way to check them.
For C, do we keep going and solve?
No, so you mean like factor, or you mean, yeah, no, because there's no, first of all, if you factor, you're going backwards. So if it said to factor, yes. Or if it said set equal to 0, then I would keep going. But this is simply just plugging in. Yep. All right, now we're going to talk about piecewise defined functions. So these are functions that change based on different values. So you will see these have multiple functions. They look something like this. And it says, in this case, it says f of x is x squared if x is less than 0. And f of x is x squared plus 1 if x is greater than or equal to 0.
It's a 2.
X squared plus 2, thank you, if x is greater than or equal to 0. So the first thing you have to do is figure out from the value that you're looking for on that question, which of the functions you're going to pick. So if f of -2 is what you're given, do I pick the top one or the bottom one? Top, good, because x is less than 0, right? -2 is less than 0, so I pick the x squared and I plug it in there. -2 squared, which is 4. It is not that you plug them both in and get 2 answers. Only one of those answers is correct. B says f of 0. So is 0 less than 0 or is it greater than or equal to 0? Greater than or equal, which means I'm going to plug it into the bottom one. And I get 0 squared plus 2, which is 2. And the last one is 3. Is 3 less than 0 or greater than or equal to 0? Greater than or equal to, so I use the bottom. 3 squared plus 2. 9 plus 2, which is 11. Now in the next section, we'll talk about graphing these, okay? And I'll teach you how to use your calculator, but for right now, we're just plugging those values in. We still good? Questions? All right, example 4 says, find the values of the function such that f of x equals 0. And all that means is take that equation and set it equal to 0. So f of x is just like a y, right? We can use those interchangeably. And these are all functions, so they'll say f of x, but you can also see them say y. And it's saying set it equal to 0. So I literally do 0 equals 14 minus 2x. And we solve. I can add the 2x or subtract the 14. It doesn't matter. And then divide by 2. And x is 7. Now, if I had graphed this line and I asked you where f of x equals 0, what is that point on your graph called? F of x is the same thing as y, right? What's it called when y equals 0? It's the x-intercept. So if I had graphed this function, it should cross my x-axis at 7. All right, B. So I'm going to set this equal to 0. And as soon as you see that x squared in the x, you should know I'm going to try to factor. So the first thing I'm going to do is try to factor. If it doesn't work, you could use quadratic. But for right now, we're going to factor. What are the factors of negative 14 that sum to negative 5? Isabel?
Negative 7 and positive 2.
Good. And then we're going to split and solve this. Set them each equal to 0. And I get x equals 7 and x equals negative 2. What would be the shape of this graph if it was on my graph? Parabola. That would cross through your axis twice, which would give you those two x coordinates. Still with me? Okay, go to C. 0 equals x to the third minus 2x squared minus 2x plus 4 over 5. What would you do first? Multiply by 5 on both sides. It's going to go away because it's getting multiplied by 0. And then I've got 4 terms. So what do we do? Good. Factor by grouping. What can you take out of the first set?
X squared.
Good. And I get x minus 2. And then what would I take off the second set so that the inside was x minus 2? A negative 2. Good. If I take out a positive 2, I would have to switch the signs because I want the insides to match. Now the insides match. So I'm going to pull that out. X minus 2 is my greatest common factor. And what's left is x squared minus 2. If that second parentheses was like the difference of two squares, if it said like x squared minus 4, x squared minus 25, I can factor further. I could take another step. But it's not a perfect square, so I'm just going to split and solve from here. And I get x equals 2, and here I get x squared equals 2. What do I do to get rid of the square? Square root, and I remember to do plus and minus. Good. So there are 3. If I looked at a graph on this, there would be 3 times it crosses my x-axis. It would cross at negative square root 2, it would cross at positive square root 2, and it would cross at 2. If you're just writing your answers for me, you can keep it as plus or minus. Don't forget your plus or minus, but you can just keep it as plus or minus. But if you're answering this question on like WebAssign, and sometimes it will say just enter all of them, you separate them with commas like I just did, and the order doesn't matter. And sometimes it would say something like enter the smallest value, enter the middle value, enter the largest value. So just pay attention to what it's asking for. You don't want to get frustrated because you're typing in the right answer but in the wrong way. And those you'll always keep exact, meaning you'll always keep them square roots. If I'm graphing it, I'm going to approximate, but if I'm listing those as answers, I will always keep them as as square roots. Still good? Yes? All right, this one says find the values of x for where f of x equals g of x. And it says f of x is x squared and g of x is 2x plus 8. What am I going to do with those? Good. I get x squared equals 2x plus 8. And then what? Good. As soon as you see x squared and x, get everything to one side. I prefer my x squared to stay positive. You don't have to do it this way. But I would move the other ones to the side with the x squared, keeping that positive. And then we're going to factor. Factors of negative 8 that sum to negative 2. Good. And then split and solve. So 2 answers, negative 2, positive 4. Questions on that? Okay, now we're going to review domain. So the domain of the function is all real numbers except if one of these 3 cases happens. If there's a variable in the denominator. And if there's a variable in the denominator, we restrict the domain by saying whatever's in the denominator can't equal 0. Because what happens if 0 is in the denominator? The function is undefined, so you literally cannot get an answer there. The second thing, so the first one, variable in the denominator. That's the first thing that makes it not all real numbers. The second thing is if there's a variable under a square root. And that restriction is that whatever's under the square root has to be greater than or equal to 0. Why does whatever's under a square root have to be greater than or equal to 0? What happens if it's not, if it's negative?
Then it's undefined.
It's an I, right? Or an imaginary number. Can you graph an imaginary number? No. So we restrict it that way. So variable under a square root is the second thing we look for. And the third is the combination of the two. The third says there's a variable under the square root in the denominator. And if that happens, then we can't say it's greater than or equal to 0 because now it's in the bottom. Now we say it has to be greater than 0. So in the denominator, not equal to 0. Under a square root, greater than or equal to 0. Both combined, greater than 0. All right, so let's find the domains of these functions. Again, the default is all real numbers. So if none of those things happen, if it just said something like f of x equals x squared, this answer is all real numbers, okay? In interval notation, which is what we're going to use, that would be negative infinity to positive infinity. So what is the range that works is how we're going to do this instead of saying what it can equal. So go to A. Is there one of my 3 scenarios I need to check for? Yep, there's a variable in the denominator. I'm not worried about the one in the top at all. I'm worried about the one in the bottom. So I say this cannot equal 0, which means x cannot equal negative 1. So the way I'm going to write this is that x is going to be able to equal everything except for negative 1. And the way I write that is it can be from negative infinity up to negative 1 with a parentheses because it cannot include negative 1. Bracket means it includes it. Parentheses means it doesn't. And then the little u for union from negative 1 with the parentheses to positive infinity. So that is how we would write x cannot equal negative 1. In words, it might say something like x or all values of x where x does not equal negative 1. It might say something like that. It might be multiple choice and say something like that. If it wants it in interval notation, then you have to write it the way we just did. I'm going to double check that I can't remember if WebAssign does interval for all the questions. All right, go to B. Is there one of the 3 cases that I have to restrict my domain? Yes, it's under a square root, right? So what do we do with that? Good. Whatever's underneath the root. So I'm not worried about the root. Whatever's underneath the root, I need to be greater than or equal to 0, which means x has to be greater than or equal to negative 3. And in interval notation, that means start at negative 3 and go to positive infinity. And this time we can include negative 3. So it gets a bracket. So bracket negative 3 to positive infinity. Questions on that one? Okay. C. God bless you. Now I've got a square root in the denominator, right? So how does that change things? Yeah, it's just kidding. It now can't include 0. So I'd say x plus 4 has to be greater than 0. X has to be greater than negative 4. And in interval notation, that starts at negative 4, goes to positive infinity. And the negative 4 gets a parentheses because it can't include it. Remember, infinity and negative infinity always get a parentheses because is there such a number as infinity? No, right? You can't give me infinity dollars. I would love for you to try, but you can't give me infinity dollars, right? That's not an amount we can, is a solid number. So they always get parentheses. Okay, and then D. This time what happened? There's 2 restrictions. In my numerator, this has to be greater than or equal to 0, but in my denominator, this has to be greater than 0. So I'm going to solve them separately and then see where they overlap. So x has to be greater than or equal to negative 4. is from my numerator, and x has to be greater than negative 1/2 is from my denominator. If it doesn't work for one of them, it can't work for either of them. So if you need a visual on this, if you need to like actually plot it on a number line and give yourself a visual, I'd recommend it. So the top one says this can go from -4 to positive infinity. Every bit number that is equal to -4 or bigger than -4 works for my numerator. But the denominator says it has to be greater than negative 1/2. So it's a parentheses and it goes to the right. And it only works for where both of them work, which means I'm looking for where it overlaps, which means negative 1/2 to positive infinity. So you're looking for the more restricted area is what you're looking for, or the smaller amount, if you think about it that way. All of them are in interval notation. That's what I was just checking. Let me see. I'm gonna go over. Okay, the only other thing that that's not on here is like what happens if I get two answers that it can't equal. So if I get, because I have to factor the denominator, if I get x can't equal -1 or +3, let's just say, then I put it in order because smaller has to come first. Interval notation always goes smaller to bigger. This would be from negative infinity to -1, parentheses, because it can't include -1. The union goes between, so just the u. And then -1 to +3 is okay. So I keep that. But then 3 to positive infinity would be the last realm. So that's how you would write a not equal of two things. Put them in order, smaller to bigger. And then we would say it can't equal those. So negative infinity to the smaller one, union, -1 to 3, union 3 to positive infinity. When you look at when you go to answer these on WebAssign, that's not a regular U, so you can't like use the U from the calculator. A little box will pop up with your special characters, and there's a U there, so be careful, okay? And same thing, like there's the thing for infinity. I think there's a shortcut for infinity. I think it's INF. But you also have the infinity from your little special character box that pops up. Questions on anything we talked about today? I'm going to stop here. We're going to do difference quotient tomorrow. So the assignment has all of this plus difference quotient. It's due Monday. My advice is to start on it while you can. 1 through 13 is what we've covered so far. And then the end questions would be difference quotient. So you can do 1 through 13 with what we did today. And then you can save those last couple for the weekend so it's a little bit lighter of a load, okay? Okay, so on the top of module 1, or chapter 1, it says, not that one, there's the thing that says prerequisite skills, what should I know already? And when you click on it, you're gonna get a page that loads that's like this. And it literally goes through the skills from Algebra 2 that are built into this chapter. So there's things on there like simplifying radicals, that like if you struggle in that area, there's extra practice, whether it's a video that I made or a video I found that is good, and then an extra practice. I say this now because in that list is factoring. If you know you're struggling a little bit with factoring, there's like 3 videos and extra practice of factoring, and also interval notation. So if you had no idea what I was talking about when I started talking about interval notation, there is a video that goes over interval notation and then a section for a practice, like a practice PDF. This is your opportunity to, if that's a skill you don't remember from last year or you never were taught it last year, that you go in and you help yourself out with it. I can obviously help you, but I can't reteach all those skills. So if you need the help, you can ask for it, but I'm not going to be able to reteach them all. So this is your opportunity to kind of catch yourself back up.